Hello, hello, hello. Can anyone hear me? Hello? Hello? Alrighty, guys and girls, thanks for joining me. We've got a few viewers, fantastic. So it does look like it's starting to work. All right, so folks, this is a subscriber video, but it's open to the public. However, I will only be answering subscriber questions on our Oz Cyclone Chaser chat room. So basically what it is you guys lead the discussion and you ask me questions using the chat room. I'll try and reply to them showing you visuals here at my end. So I've got this option here to screen share things. So if I'm looking, say, at a model, I can click on the model and show you the model, and so you can have a look at what I'm looking at so you know what I'm talking about. Otherwise, it would sound pretty silly and you wouldn't understand what the hell I'm on about. And when I'm finished showing you that model, we can come back to me. All right, I'm still learning how to use this, by the way, and this is the first time of many times that we'll be doing this. So we'll be alternating between screen share and having a look at my ugly mug as well while I read your questions. All right, so if you have asked a question way back in the chat room, because we've got a fairly upbeat chat room there. So all right, so let's have a look. Have to say, great work, Nitso. Fantastic stuff this year with the added extras. Love it. Thanks, Posty. I can't take all the credit though. That's a lot of that stuff is from Shane. Shane is our tech genius, and this is why Shane's not involved tonight. This is why this was going haywire. So I'm sure if Shane was here, we'd be able to get this running straight away. All right, so Asun, g'day Nitro. Well, I think he means Nitso. Awesome stuff. I have a question. Could you explain what LI and CAPE are? You use them when explaining the expected severe storms on the BSCH model. Okay, so LI is a term we use for, it means lifted index. So that's what it stands for. Lifted index is basically at its most basic level, a example of how buoyant or how much warmer an air parcel is compared to its surrounding environment. So warm air rises, and that's pretty basic stuff. But the warmer the air, the faster it rises. So a lifted index, say, of -7 means that that air will rise very, very fast, whereas a lifted index of, say, -1 means, yes, the air will rise, but it's pretty close to the temperature of its surrounding environment. And so therefore, it's not going to rise very fast. So we're only looking at very, very weak instability. CAPE is a measure of the available potential energy in the atmosphere, and it's very, very much linked to LI because it's a measure of the distance between the parcel that's rising compared to the environment around it, and it's the area in between those curves. It's very difficult for me to explain without getting without getting some scientific images up. And tonight is probably not the night for me to explain those things. I might do a Q&A though in the future when there's not so much activity, and perhaps you can ask that question again, and I can give you some demonstrations in some graphs. But tonight I really want to focus on the cyclone rather than just general weather. But that's at its basic level. So what we want is really low LIs, and we want really high CAPE. So if we get those two things, then we've got a lot of instability in the atmosphere, but we also need moisture. So it doesn't matter if you've got negative 12 LIs and 5,000 CAPE. If you don't have any moisture, there's not going to be any cloud formation. There's not going to be any condensation. Okay, so that's why we can't just use, and I know some other weather places do use just LI and CAPE, and that's why they can be so misleading. Jarlian says he can't hear me, and the track map, whoop, we are now 2. So I'm assuming that means from Jarlian, and we'll just have a look and see if we can get the weather map, see if we can get the latest Bureau of Meteorology up and show it to you, and we'll see what they've done with the latest track map. I can't imagine there's too many surprises, but the system has certainly intensified. And yep, definitely. And what we can see, and if I just screen share that with you, screen share what I'm looking at with you, so bear with me. All right, and here it is. So you should be seeing on your screens now, and let me know if you're not, but you should be seeing the tropical cyclone advice and track map. And you can see here it has been upgraded to a category 2. Still a very asymmetrical system. So if for those of you that should, by now a lot of you should know what that means. It basically means it's a lopsided system. To the south, it doesn't pack too much of a punch until you're right near the core. To the north, it'll pack gale force winds and damaging wind gusts for a lot further in terms of area. And that's what I meant in tonight's video update, that we will see probably the worst of the effects of this system as it's crossing the coast or just after it crosses the coast. So for those, I know there was a question earlier saying, where's our rain in Port Hedland? It is coming. It's more likely to happen, though, as the system's crossing the coast or after it has actually gone inland. So it was a good question, by the way. I do remember seeing it when we had our couple of issues there. All right, so let's go back into the chat room and let's have a look at what other people are asking there. Hey Nitzo, this is from Freebooter. Hey Nitzo, when you talk wind shear, the lines are in yellow. What are the white lines that are in an anti-clockwise direction? Now, sometimes those white lines, and I'll just get a shear map up here for you, so you can see what I'm talking about. Let me just do that. So while you're looking at me and I'm looking blankly, it means I'm trying to get the maps up that I need to show you what's going on. All right, so what I'm going to do now is I'm going to screen share. And I'm going to give you a look here at what I'm looking at. All right, so we're looking here at a wind shear forecast or a current wind shear analysis. And the issue is, or the question is, what are these white lines? These white lines show us which direction the shear is coming from. So sometimes in the Bureau of Meteorology's technical outlook, you'll find that they're saying the system is going through moderate levels of vertical wind shear, and they'll say that that wind shear is easterly. So that means that the shear is coming from east and pushing the thunderstorms away to the west. So currently, with our tropical cyclone here, it's in between the 20 and the 30 knot mark in terms of wind shear. So it's going through a fair amount of wind shear, but that shear is decreasing and decreasing very quickly. And the forecast shear is actually decreasing in and around the system too. So we have a situation here where the system is very likely to intensify and quite rapidly between now until landfall. Good question there from Freebird. Oh, by the way, they don't always go anti-clockwise, these shear lines. This just shows us that we've got a bit of an anti-cyclone here on the right side of the system, to the east of the system. Sometimes you'll find that those shear lines will actually move towards a low rather than away from an anti-cyclone. So they don't always travel away like this in an anti-clockwise direction. Good question. All right, let's have a look now at our next question and come back to my big ugly mug. And what are we looking at here? Pico, hey Nitzo, how does the temperature differential in the atmosphere feed the system after landfall? Oh, that's a good question. All right, so what ends up happening is that as we get cooler air in the upper levels of the atmosphere, the uplift associated with the convection is enhanced. So even though we lose the latent heat release from the ocean, so because we don't have that heat-driven oceanic effect, what we then have is a situation where the energy is fed because of that temperature differential between the lower levels of the atmosphere, which are still very warm, but the upper levels of the atmosphere, which are now very cold. And as long as we still have moisture advecting into the surface or the lower levels of the system can still grow very deep and strong convection. And this is why in this particular situation, this tropical cyclone will not weaken very quickly once it hits landfall. And that's why the Bureau have extended that warning area. And if we look back at the tropical cyclone threat map, and I'll just screen share that again, just so you can see what I'm looking at. This is why we have such a large extent further inland here, and you can see it all the way almost to Newman, and that's because as the system hits land, the upper trough starts to approach the system, and we see cooler upper level air entering the domain of the circulation. And so even though it loses that heat and that moisture at the surface, or not totally that moisture at the surface, but loses that that oceanic influence, it's still able to continue to maintain some level of intensity. Now, when it becomes a purely temperature-driven system, as opposed to a surface-based system, we tend to, or what we call it's extratropical transitioning, because it's now no longer getting its energy from the ocean, it's getting its energy from that temperature differential. That's a great question. All right, let's move on, and looking at my ugly mug again while I look at the next question. All right, fantastic. No worries, we can, fantastic. Yep, got you talking, fantastic. I can't hear a thing, Posty. Posty, have you turned up your own speakers? Otherwise, perhaps YouTube has automatically muted the video. So if you do need to, you might need to just play around with your settings on YouTube if you can't hear me. Once Stan smashes the coast, how far inland will it go with rain? Good question, Boots. All right, let's have a look. Let's have a look at that, and we'll use the European computer model because it looks like that's the one the Bureau of Meteorology moving towards, following in the track forecast. So bear with me while I find the Euro model, and then I'll screen share it once I've done that, so you can see what I'm looking at. I'll also get up the Access Regional model, and the Access Regional model is also a fairly useful model, especially in the first 24 to 48 hours. Once it goes after about 48 to 72 hours, the Access Regional model goes a little silly. All right, so let me screen share now. Oh, let me change that. All right. All right, this is a beautiful resource. This is WonderMap, and WonderMap allows you over here to play with different various models here. So I'm looking at the Euro, which is the most globally the best model. It's not the highest resolution. The GFS is the highest resolution model, but the Euro tends to be a lot more accurate in general. All right, so let's have a look at the precipitation. We won't just talk about inland precipitation. We'll talk about precipitation in general from this system. And so we're going to start at around about 2 a.m. So these are our time frames or timestamps up here. Friday the 29th of January, which is actually in our time, Saturday the 30th of January, because it's 1800 GMT, which is in WA time, it's 2 a.m. So at 2 a.m. we can see that most of the heavier rainfall is just offshore here off the Pilbara coastline. Then as we move towards 5 a.m. in the morning, we see once again most of it just either right on the coast or just off the coast. So you can see here, if we just zoom into Port Hedland, for instance, you can see they're only getting fairly light rain. If we move over to the west here for Karratha, we can see that those folks too are only getting fairly light rain, with most of the heavier stuff just offshore. Now, as we go to 8 a.m. and let's have a look at what happens at 8 a.m. My system's just going a bit slow there, probably because I've got so many tabs open. All right, so at 8 a.m. here, we can see once again most of the rainfall remaining just offshore. There is that enhanced rainfall here around 80 Mile Beach, between Pardu and 80 Mile Beach. Now, the reasoning for that, of course, is that we're seeing these northerly winds coming onto the coastline here along that part of the coast. So in and around Port Hedland, we're not seeing those northerly winds, so we're not getting that convergence and that moisture advection. So we're not seeing very heavy rainfall yet. So this is very close to landfall, by the way. Now we're looking at 11 a.m. in the morning, and we can see that the system not located too far offshore here, but not too much rainfall around Port Hedland, not too much rainfall around Karratha. And you can see most of the rainfall is located well east here, even east of Pardu. All right, as we go to 2 p.m. tomorrow, this is right on or very close to landfall here around the De Grey to Pardu area. And you can see it's only now that we're starting to see some moderate falls of rain here along the coast and getting to becoming quite heavy further to the east. All right, now, as we move on to 5 p.m. tomorrow, as the system makes landfall, expected to make landfall to the east of Port Hedland at the moment, but that can change. Remember, of course, as I talked about tonight, those little slight eye wobbles will result in slight variations to that track forecast. But have a look here, as the system's making landfall, this is when we start to see the really heavy rain making it onto the coast. So you can see anywhere from Karratha all the way to Port Hedland is now expecting that heavy rainfall as the system makes landfall. So don't expect too much rainfall before the system makes landfall. Most of it's going to happen as it's hitting or after it's hitting. Have a look at this now. After it's actually hit the coast and started to move inland, we've got a lot of rainfall making it onto the coast here around Port Hedland to De Grey. Now, as we go in towards tomorrow evening. So we're now looking at around about 11 p.m. tomorrow night WA time. System is now located inland. It's still quite intense, so you're still getting a lot of feed in here with the moisture. The system hasn't lost much of its structure, so you can see that it's very symmetrical still. And we're seeing some extreme rainfall here just to the east of Port Hedland between 8 p.m. and 11 p.m. tomorrow night. As we move on to 11 p.m. to 2 a.m. tomorrow, you can see that the system moves further inland and starts to accelerate. That's something I did mention in tonight's update as well, is that the system will accelerate once it hits the coast. And you can see here the heavy rain is now starting to leave the Port Hedland region. Karratha probably only looking at a period of a few hours of moderate rainfall. Other than that, the system has probably gone just a little bit too far east for you to receive any good rainfall from it. All the good stuff's going to be more in the vicinity of its coastal crossing region. All right, as we move towards 5 a.m. here, the system's traveling towards the southeast. It's gone through Marble Bar, it's gone through Nullagine, and you can see that, I'll just zoom out here so we can get a few more locations, and just bear with me, there it is. I'm hoping you guys can see this, by the way. I'm just going to check the chat to make sure you can, otherwise you'll be thinking I'm a raving lunatic and you won't know what I'm talking about. Okay, it looks like you can see it, so that's fantastic news. All right, so as we go towards 5 a.m. in the morning tomorrow, 5 a.m. in the morning on Sunday, we can see the system located here to the southeast of Marble Bar. We can see a lot of heavy rainfall associated with it in that 3-hour period, but you can see lighter falls now along the coastline, so it all does ease up fairly quickly on the Sunday in terms of rainfall here. The system then continues tracking to the southeast, and you can see continuation of very heavy rainfall. Now, a lot of this is because also the trough is enhancing the thunderstorm activity and the convergence. So you can see most of the convergence here to the west of the actual circulation. So the circulation is here where my cursor is, but the heavier rain is actually west of it. And that's a very, very clear indication that the system is now coming under the influence of a trough system to its west, that we're seeing that. And we have a situation then as we go towards Sunday in the early to mid-afternoon period where we have showers and thunderstorms wrapping around the system, continuing to wrap around the system, and bringing in a feeder band from the desert as well, believe it or not. So we've got, it's going to be a significant rain producer across inland parts of WA. There's very little doubt about that. And you can see the trough system back here to its west, and that continues to enhance the thunderstorm activity throughout the forecast period. And even when we track it through to the border of WA and South Australia, you can see it here. It's still producing massive amounts of rain. The good news, of course, in terms of flood threats is that, yes, there might be some flash flooding, but there's unlikely to be very heavy and prolonged rainfall. So yes, you're going to see very heavy rainfall for, say, 3 to 6 hours, but it's not going to last for very long. So you might get 50 mils in that 3 to 6 hours, but it won't be 50 mils over, 6 hours over 24 hours. So you're not going to see accumulated falls of 200 plus millimeters as it pushes to the southeast. But in saying that, to the area up here around Port Hedland, with the assistance of that extra bit of moisture from the ocean, and obviously with a stronger system and a slower moving system, you could see accumulated falls getting up there between the 100 to 200 millimeter mark. And in fact, let's have a look at the Access regional model, and let's have a look at what it's predicting as accumulation of rainfall totals. Just bear with me again. You're going to see my ugly mug while I get that up on screen for you. All right. Go into my just bear with me, folks. I've just got to get this up. I wasn't planning on showing this one, but I think it's very relevant. And why aren't we showing? No, it doesn't want to show us anything. That's concerning. Just yep, give me a minute or two, folks, as I do this. Keep chatting amongst yourselves. I'll come back to you as soon as I've got this up. Bear with me, folks. I'm still there. I'm just trying to get this, trying to get the right chart up. All right. Let's see if we can get that one up there. All right. So, folks, what we're looking at here is the accumulation over the next 3 days of rainfall according to a fairly high resolution model here, the Access Regional. So you can see here around about 100 millimeters is expected, or over 100 millimeters is expected on large parts of the East Pilbara coastline, and also those falls of 50 to 100 are extending further to the southeast. If we have a look at how that compares to the OCF computer forecast guidance, and just bear with me while I get that up for you. And here we go. Where's the BOMS OCF? 24-hour rainfall. And we're looking for tomorrow. And let's share that with you. Alrighty, so here's the OCF. So this is a conglomerate of computer models here showing us the expected rainfall for Saturday, then the expected rainfall for Sunday. You can see once again fairly heavy up around that Port Hedland area. But if we just go back to Saturday and just have a look there, it's only just extending west to Karratha, and I would dare say that Karratha, you're probably not looking at all that much, considering that the system is expected to now hit the coast just east of Port Hedland. But you can see falls of up to 100 millimetres there right along the coast on the Saturday. In the Sunday, as you can see here, the system's tracked fairly quickly to the southeast, and we have moderate falls of rain extending a long way further to the southeast now, associated both with the system and the trough, and then moving into the WA-SA border. All right, so I think I've covered precipitation fairly fairly extensively there. So let's have a look at our next All right, let's have a look. Posty, no, I've tried watching it. I go through the website, bleep noise, tried 2 different browsers. Cheers, Donnie. We've got a couple of OCC rocks. Session. Okay. I love to see them. Is that an iron? Yeah, it is an iron. The office does double as the place to iron clothes as well. So, the beauty of having a home office. All right, not in WA though. I heard a whisper about another one over this way in 10 days or so. Ooh, HJP, very interesting. Okay, you have heard a whisper, have you? All right, let's have a look at what the models are whispering. So HJP has said that he has heard a whisper about another tropical low or tropical cyclone over in WA in the next 10 days or so. So let's have a look at what that looks like on some of the guidance. And you're not too far off the mark there, HJ, and if we just have a look at some of the longer term, and we'll just go to tropical tidbits and have a look there at what the ensembles are doing. And just bear with me once again. You're probably seeing my ugly mug and going, what's he doing? I'm getting up a couple of forecast computer models, and I'm going to give you a look at those because yes, they do show a little bit of mischief happening over WA in the future. All right, so the first one we're going to have a look at is the European. And here we go. We ready? And let's screen share that for you. This is thanks to tropicaltidbits.com, another great resource for computer forecast modeling. Fantastic resource. I do encourage you to go and have a look at them. Tropicaltidbits.com. All right, so from there, what I do is I select the computer model that I want to look at. So for this one, it was the Euro. And from there, I will go down to the region I want to look at, which at the moment is Australia, of course. And then I can just use my slider here and change the time frame. So what we're looking at now is there is a low expected to form here up around the Gulf as well. Now that is expected to eventually track west into the base of the top end. Now it could, and I do stress the word could because it's so weak, we just don't know what it's going to do. But it could pop out here near the Joseph Bonaparte Gulf, then it move in a west-southwesterly direction and pop off the coast here around about Derby. And you can see it here in about 9 days' time, located off the coast here of the north of the West Kimberley, I should say, and starting to consolidate itself at day 10. So yes, there is a whisper, but it's still a very, very quiet whisper. There's not, it's not set in stone, and it's not a major cyclone signal that we're seeing in the short to medium term anyway. So there is certainly the possibility there for something to move that way, and look, I'd be surprised if that Gulf or NT low doesn't move that way in the medium term, but I don't think we can start calling it a cyclone chance just yet. All right, hope that answers your whisper comment, HJ. All right, let's go back to my ugly mug. And let me go back to the, all right, Chase Sandfire. I'd love to see them in Karratha. Oh, we'd love to go to Karratha, Andy, trust me. Do the BOM use the same model as you guys at OCC? As soon, good question. The BOM do use all of the models that we use, plus they have extras that we don't have access to. They have some really, really awesome stuff. In fact, they have top secret extra access to the very latest version of the European forecast model. The European forecast model, as you know, is the one that we tend to is our go-to model. The Bureau of Meteorology now have access to their brand new model, which won't be released to the public for another 35 days. But once it is released to the public, it'll be pretty awesome, especially when it comes to tropical cyclones. Because at the moment, as you know, the biggest issue we have, and this is why we didn't chase this system, is that the computer models are so bad at picking up intensity of systems. So up until probably today, it was just saying that this system would be a category 1, category 1, category 1, and hitting the coast as a 1. And so we were thinking, you know, why would we want to do that? And it was only when I really looked at the situation yesterday where I thought, this is not going to be a category 1. There is no way that a system like this going into this sort of environment could be a category 1. But you know what? By that stage, it was too late because we couldn't get a flight and the rest is history. But the new European model is such high resolution, so high resolution, that it is so much better at picking up tropical cyclone possible intensity into the future. Just amazing. And I have seen some really good comparisons, which I'm not technically allowed to show you, but you know, where the normal European that we use was showing a system at 970, the real top-notch Euro, the one that's coming out shortly, was showing it at 940. Guess what? The system was 940. And there were numerous examples like this. So I think it's going to be a huge step forward, this model, once it comes out to us and is available to us in March, in terms of cyclone intensity forecasting. To answer your question, sorry, I digress a bit. But to answer your question, the Bureau of Meteorology use very much the same models we do, but they have also some extras that we don't have access to. So we have to make a guess, an opinion on what we do have access to. They have a lot more tools at their disposal, if you like, than we do. All right. Yep, on these models. I'm not sure what that means from Posty. All right, 5th to 8th. Nitso, how does wind shear affect the angle of indraft? Freebirder, I'm not sure what that question means. How does wind shear affect the angle of indraft? I'm thinking maybe you mean how does it affect the angle of updraft? So what will happen is that if we get a lot of wind shear, so if we get really, really strong winds at the top of the atmosphere and we have really, you know, weakish winds in the middle, what will happen is that those winds at the top of the atmosphere will chop the top of the storms off, and will try and move them away. So the angle of the updraft will be straight, and then bang, it'll hit this strong wind, and the updraft will be pulled or completely eroded off at the top there. So I'm not exactly sure what you're trying to ask me there, but that's generally the effect that wind shear has. Now, if we see shear generally increasing as we go up in the atmosphere, that tends to be a good indicator for severe weather. So let's say we have 20 knots coming in from the east, and I'm hoping you can see this, otherwise it doesn't look, and you don't know what I'm doing. But if we have 20 knots of wind coming in from the east, and then, you know, just above that we might have 20 knots coming in from the north, and then just above that we might have 40 knots coming in from the northwest. So what will end up happening is that the updraft will try and move up and rotate as it goes up. So it'll rotate up as it goes up, and that's what creates a lot of what we call those supercell thunderstorms. So when you hear people calling every second thunderstorm a supercell, it's not. Supercell thunderstorms are specifically rotating storms, and they have to rotate at a certain level. So some storms, or many storms, rotate very, very gently, but these supercells rotate violently as the updraft goes up. So it's almost like a corkscrew as it goes up. And that's what creates the really intense and severe weather that we see, sometimes the tornadoes that we see, and that sort of thing. So that's where that's how wind shear can affect the updraft, I think you're talking about there, Freebirder. Jace Earl says, hey Nitso, I love your work. Next time, I think don't look at the computer models and go for a chase in WA. Go on your instinct. Oh, look, if it was just me, I'd do it. And I would have done it for this one because I looked at this one, and as I said, I looked at it, and without a computer model, I know what these do in Queensland. And if this exact situation was played out in Queensland, and there was an upper level high to the east and an upper level trough to the west, just like Cyclone Marsha last year, exactly the same dynamics, you just know it's going to bomb, and you just know it's going to happen. And you know, it's, I guess in a way it's my inexperience in Western Australia. I haven't chased there all that often, you know, and personally I'm only 32, so I'm only still learning the ropes. I'm still not a seasoned chaser. I don't consider myself a seasoned chaser. I do have a sound knowledge of things, but I don't have the confidence yet. Maybe in 5 or 6 years time, if that same situation happened again, I wouldn't even blink. I'd have gone straight away. But for now, I am at the mercy a little bit in the computer modeling. Plus, you've got to remember that I've got to make decisions for the entire team. So if I say we're going, it's a significant investment. It's not just me, just, you know, jet setting over there and sitting in a motel for a couple of days. It's not like that. So it's a fairly big decision, and I've got to base that decision on science. I can't base it on hunches and gut feelings. And as much as I know chasing a lot of the time is gut feeling, I need to be able to justify it. If we're going to chase and it's going to cost us $5,000-$6,000 to get there as a team, and we get it wrong, I need to be able to say, well, we got it wrong but we still went through the right processes. Look, this was showing that it was going to happen. This was doing this. Whereas if I got it wrong this time, I wouldn't be able to do it. I wouldn't be able to justify that expense. So that also goes through my head. But thanks very much for your support there, Jason. Andy76, do you know if big mining companies get advanced information on cyclones? Yes, Andy, they absolutely do. Andy, what they normally do is big mining companies will pay the Bureau of Meteorology a lot of money. Oh, I won't tell you how much money, a lot of money. The Bureau of Meteorology will provide them with monthly forecasts for tropical cyclones. So they will know up to a month in advance of when cyclone activity is expected to increase. They won't know exactly where the cyclone will be because no one knows that, but they will know when cyclones are expected to increase. And that's what we do with the Future Aussie Cyclones video. Sometimes things creep up on you. This one here crept up on us because it wasn't expected to develop until about a week or so out. We only started looking at this one about a week or so away, and the mining companies, they would have been a little bit cranky, I'd imagine, because they wouldn't have had a heads up for much longer than you guys did in terms of this system, because at no time was this on the radar 3 or 4 weeks out. All right, so hopefully that does answer your question. Also, Andy, the mining companies do get a specific commercial weather service from the Bureau, and that provides them with a little bit more information about the cyclone than you and I would get as a public member. All right, soon. Question regarding tropical cyclone categories. What steering mechanisms play main role as they transition up in the strength? Yes, great question again, soon. All right, as a tropical cyclone deepens, and it's more so the deeper structure results in slightly different steering mechanisms in play. So one of the really awesome, and I'll try and get it up here if I can remember the let me think if I can remember the link, because I don't have this one bookmarked. So I'll try and get it up here and screen share it for you. And just bear with me again, folks. I'm just going to go silent for a bit while I get this up. Deep layer mean. It's a great question, Asun, and yeah, definitely. There it is. Fantastic. All right, I'm just going to screen share this with you now, and I'm going to make it a little bit more relevant. So we're going to go to the West Australian Basin, not the East Australian Basin. All righty. All right, now I'm going to screen share this with you, so you're going to be rid of my ugly mug for a bit, and There we go. All right. So this is the steering layer mechanisms for particular systems. Now, you know, when we're talking about a very weak and shallow low, we're talking about this steering layer. So this steering layer is the 700 to 850 hectopascal level. So it's around about 1.5 to 3 kilometers up in the atmosphere. This is what guides really, really, really weak lows. So you know how sometimes in my video updates I talk about if the system is strong, it's going to go this way, but if the system is weak, it's going to go this way. And there's a huge difference in the ways I'm talking there, because a lot of the time the steering at the lower levels is completely opposite to what's happening in the upper levels. So in here, in this situation here, we have a steering mechanism that will track the system in the lower levels towards the southeast. And it's a fairly weak steering mechanism, and this is what we can see here by the lack of color. So instead of this green shading, the cyclone is located over blue shading, which means that the steering layer here is very, very weak. Now, let's have a look at how tropical cyclones, as they intensify, are steered by different levels. Now, when we get to category 1, this is the level that steers a cyclone predominantly. This is the steering layer at 500 to 850 hectopascals. So we're talking here between about 1.5 kilometers to now we're going up 5 kilometers or 5 to 6 kilometers into the atmosphere. This is what's going to steer a tropical cyclone at this level of intensity. So these sort of cyclones aren't very deep, aren't very strong, and tend to be governed by what's happening more in the mid-levels of the atmosphere rather than the upper levels of the atmosphere. So you can see here, if the system was a category 1, it would adopt a more easterly track. So you could see here moving towards the southeast, probably towards 80 Mile Beach area. Now, let's see what happens when we start looking at a category 2. Now, category 2 is governed by a steering mechanism that is slightly higher, so slightly deeper, I should say. So we're looking here from around about 1.5 kilometers to about 6.5 kilometers into the atmosphere. And you can see here, once again, fairly weak steering, so the system's not going to move very quickly today, and we're seeing that at the moment. It's only moving at about 10k an hour, so it's doing that. Now, as the system intensifies, if the system intensifies further, we start looking at a really deep layer mean steering flow. So we start looking at the steering flow from 1.5 kilometers all the way up to the top of the atmosphere, or to the top of the weather-producing atmosphere, if you like, which is around about that 300 hectopascal level. Now, once again, you can see fairly weak steering environment here for the system. You can see this upper trough here. Located very, very clearly now, can't you? Very clear upper level trough, very strong upper level trough. And this is what's actually making the system or allowing the system to become stronger than it would normally be. Let's say the system developed into a monster. Let's say it developed into a Cat 5. Now, in a Cat 5, it doesn't care what's happening at the surface. So we don't use the 850 hectopascal level at all in a Cat 5. The levels that we use for a Cat 5 are the 200, 300, 500, and to a lesser extent, the 700 hectopascal level, because what happens in the top half of the atmosphere will govern the direction a Cat 5 will move a lot more than what happens in the bottom half of the atmosphere. So, for instance, in a Cat 1, we really only look at the bottom half of the atmosphere. For a Cat 5, we really only look at the top half of the atmosphere. So it's a great question, and that's the general progression. Now, bear in mind, of course, as a cyclone firstly develops, it develops some really deep convection. So even a category 1, a fast intensifying category 1, can be governed by the 500 to 700 hectopascal level if it's got very deep convection. So you can't just, this isn't a one size fits all thing. This is you've got to play it by ear. You've got to play it cyclone to cyclone. But in general, after numerous studies over decades, this is what they've come up with. This is what the professional meteorologists have come up with as the guiding steering layers for tropical cyclones on a general basis. Hope that answers your question. All right, let's see if we've got any new ones. Oil rigs off Dampier were evacuated 2 days ago. Yeah. When stand hits the 20 knot zone, can it stall there, or does it speed up? Boots 1981 has asked if Stan hits that 20 knots of shear, will it stall or will it speed up? Look, shear probably won't make it do anything. So if it moves into limited wind shear, it just means that the winds in all levels of the atmosphere are probably going in the same direction. All right, so the fact that it goes through that 20 knot barrier that I mentioned doesn't actually have any real effect on its speed as such. So shear and speed of travel are two separate things. They can be tied into each other. So if you tend to go through 50 knots worth of shear, the system tends to accelerate very quickly towards the direction the shear is going. But in general, or it just dies because it tries to counteract that force, and it'll just die. So it has one of two options. It can try to withstand the force and die, or move with the force and survive for another 12 hours or so. But ordinarily, if the shear drops, don't tend to see too much effect on speed. Donnie C. Tropical cyclones seem to be bombing regularly lately before landfall. Marsha, Patricia, and now Stan as examples. What has happened to allow for this to compare to the last decade or so? Well, Donnie C, I think I don't know if you certainly can't call it climate change. You certainly can't call it climate change. What you can look at though are where these cyclones develop in relation to what's happening elsewhere in the atmosphere. And those three that you're talking about, Marsha, Patricia, Stan, look, they're forming in this area between an upper ridge and an upper trough. And that is the perfect cyclone area. So if the system develops over an upper ridge, yes, it's got very limited wind shear, but it also doesn't have excellent outflow. If the system develops in an upper trough or near an upper trough, the system has too much shear, and it's got great outflow, but too much shear, so it can't build those storms. If the system develops in between those two, and remember, of course, that the trough will move from west to east in general. The system will go through a low vertical shear phase. It will slowly and gradually develop, and then what will happen is this upper trough will push in underneath it, and just before it hits the cyclone with all this wind shear, it will enhance this outflow channel and what we call this exhaust system to the south. And that exhaust system will give it that kickstart, that really, it'll be like a turbocharger to the cyclone. And this is what's happening with these systems that you're mentioning. And these are the telltale signs. When you see an upper high and you see an upper trough and you see there's a fair gap between them and you see the cyclone in that gap, that is one of those really, really, red flags, if you like. It's a red flag to a bull. When you see those two things, you know that something's bound to happen. Andy asks, hey Nitso, have you considered chasing severe tropical cyclone with the guys from iCyclone? Definitely, and we talk to Josh about that fairly frequently. As soon as there's even a hint of a Category 1 in Australia, we go and talk to Josh and try to get him over here. Look, Josh will come over and we will definitely chase. I can almost guarantee that, as long as we're both still alive after chasing. We will definitely chase together, I'm sure of it, in the coming couple of years. So we're very much looking forward to that. We might even chase offshore next year, or this year in the Northern Hemisphere season. We might even see if that's a possibility. But we are definitely very keen to join up with iCyclone. He is the master. We are the apprentices when it comes to chasing tropical cyclones, and I have no qualms in saying that at all. He's a man that I've looked up to ever since I first started chasing storms. So it would be a bit of a dream for me to chase with a bloke like that, who's that knowledgeable and has that much experience and so many notches under his belt in terms of what he does. So we just admire everything that iCyclone and Josh in particular does. So we would love to chase with them, and I'm sure that time will come. All right. What creates the difference between a strong and weak MJO? Well, if I knew the answer to that, which I don't, I don't know, I'd probably write my own meteorological journal. It's such a complex little thing, the MJ, or big thing, the MJO, and I'm not sure if anyone fully understands that the how it can go from a strong to a weak, or weak to a strong MJO. And yeah, I really can't answer that one for you, Danny. I'm not gonna lie to you. I'm not gonna BS you. That's one area that I just simply don't know, and that's probably something you probably need to ask a meteorologist, and not just any meteorologist. You need to ask a meteorologist that studies that particular phenomenon, because that is certainly it's a very expert field, that part of meteorology. When we start talking about MJOs, Rossby waves, Kelvin waves, those things, that is an expert field that not all meteorologists know about. So you're probably going to have to talk to one of them to get a good answer for that one. So I'm sorry, Danny, I can't answer that one for you. Pico, in the longer term, is this system going to take any rain to areas that need it as it goes inland over the next week? Pico, I'm not really sure. We've gone through rainfall. We've gone through rainfall at length a little earlier. Now, I'm not sure what areas in WA need this rain, but if you have a look here, I'm not going to go through this very long at length again, but just have a look here at where the rain is falling. So this is Western Australia. Oh, let me just screen share this. Yep, screen shared. So just keep an eye on this. Now these are rainfall in inches over 3 hours. So have a look at where the rain is falling, and you tell me if it's going through areas that really need it in WA. As I'm unclear on exactly how much of WA is drought stricken. So have a look at it over the next couple of days as it moves southeast, and then we'll continue looking at it in the longer term for you, and we'll track it into South Australia and see where the rain falls in South Australia for you. So you can see now much of the rain is actually offshore, but still producing some very heavy falls and linking up with a trough system as well in the longer term. So you can see there it's located right near Adelaide. That'll be pretty awesome for them if they get some rain out of it, wouldn't it? And then the remnants of the system is located up here, somewhere between New South Wales and South Australia. So you can see the system pretty well washes out into a bit of a trough. And what's it doing there? It moves a little bit further to the north, and I think eventually there's a couple of things that happen. I think eventually there's a little low that develops here off the coast of Rocky to Gladstone, and that low will produce some phenomenal rainfall, or is expected to produce some phenomenal rainfall. But whether or not that's on land or just offshore, we're not sure. So look, the system has the potential to move all across Australia, which is, you know, a pretty awesome achievement. But whether or not it actually, you know, it's actually much of a feature by the time it gets into Queensland, you know, it's difficult to say. But at the moment there, it looks more like a trough that's creating all this rain for Queensland rather than that particular remnant of the low. All right, I hope that answers your question. How rare are upper level lows at this time of year? Look, they're rare, but they're not something you've never seen before. So as soon, by the way, I asked in case you didn't hear it, how rare are upper level lows at this time of year? Look, there's no doubt that the monster upper level low that we've got in the east, and let's just go to that, and I'll show you what I'm talking about. Just bear with me. I'm just going to put you on screen share. All right. No, that didn't work. Good on you, Nitso. All right. There's no doubt that to see something like this is phenomenal. This is not a regular occurrence. This is something that we see. Do you remember all that hype and hoo-ha and bull about that Antarctic super low or Antarctic vortex? That's the sort of upper low this is, except it's in the summer. So this is, it is very unusual, no doubt about that, but not unprecedented. Unusual, but not unprecedented. And remember, as I said in the, I forget which update, I think it might have been the Queensland update, I said that it's this right front quadrant that creates all the weather in this situation, and it's this right front quadrant that we see the severe weather, because that's where we tend to see that moisture being fed into the system, and then we see that colder air pushing in aloft. So we see that enhanced instability, and we see convergence at the surface. So we see a lot of things happening on this northeastern edge of that upper low. So wherever that upper low is, to the northeast of that is where we're seeing the most severe weather. All right, let me go back to our chat room and let's see if we've got any more questions. All right, so Boots 1981 asked me how many fish did you catch Australia Day. I would be lying to say that I was in too much of a I'd be lying to say that I was in too much of a mood to catch too many fish that day. We had a good storm the night before, and I may have had a few cokes, in inverted commas, watching that storm overnight, and I wasn't really up to having too many fishing adventures. Any signs of a coral sea low? Asked Danny. Oh, look, Danny, I'd love to say yes, and look, I will say yes eventually, but probably not until middle to late February, I think, is the latest that I've seen, around about the third week of February. Now, we are looking at a Gulf of Carpentaria low, possibly hitting the Western Peninsula, crossing the North Queensland coastline and developing into a cyclone in the Coral Sea. So that is the latest in the long-term modelling, is showing us that situation. So as I say, developing in the Gulf, hitting the Western Peninsula, crossing North Queensland, so dumping a fair amount of rain across North and far North Queensland, and then developing into a cyclone in the Coral Sea and tracking east away from Queensland. That is the also an effect of the MJO, as Andy says here, going crazy. So we're expecting to see that happen sometime around mid-February. So I would say next week, I think, will be a quiet week when it comes to cyclones. Once obviously Stan has hit the coast, next week will be a quiet week. The week after, she's on. All right, so get set for the week after, particularly towards the end of that week. Donnie C, since the cyclone season got off later than usual, does that mean it could extend further than normal? No, there's no signs that the cyclone season will go later than normal this year. Sorry, Donnie. Nitso Weather Zone has a low in North WA. Yes, we've already had a quick look at that, Posty, and we did mention it on the European forecast model. So let me get that up for you, and I won't go into it too much detail because we've already talked about it, but I'll just get that up for you, and we'll have another look at it. Where are we? No, it doesn't want to come up for me. Hang on. European. Right, so where are we? All right, I'm just going to screen share this with you. Have a look at it, and there we go. All right, so what we're looking at here, Donny, is the system that's going to form in the Gulf. Now, I've talked about that in the NT update today, and we talked about the weak low that's forming up either near the Gulf or near the Arnhem Coast. And we're going to see that move in a general southwesterly direction across the base of the top end. Now, there is the possibility here that in around about 8 to 10 days' time, it might pop off the West Kimberley coastline here and once again have reasonable chance of developing into something a little more major. But at this stage, there's too many variables to be telling you that with any confidence. So as I say, we have talked about this a little bit earlier, and we've also talked about it in the NT update if you watch that video as well. So I hope that answers your question. All right. Bummer, cheers. Seriously, next a clone fix. I don't know what that means. Any news on if the long-range forecast? Yes, the long-range forecast ASOON is for a La Nina next year. Reasonable confidence in that. Andy, 76. In your view, Nitso, why are WA low cyclones easier to predict than Queensland? Because it's an interesting question. They're easier to predict in terms of their movement. They're much more difficult to predict in terms of their intensity. Queensland cyclones, we tend to know around about. I'll say Marshall was an exception, but we tend to know around about how strong they're going to be. With WA cyclones, because there's so much so many problems. You know, in WA, in a perfect world in WA, every cyclone would be a Cat 5, Cat 5 plus, because they have such warm ocean temperatures. When they've got that monsoon above them up there in the Timor Sea, they've got so much moisture. So they'd all should be technically Cat 5 pluses, but they're not. And the reason they're not is that we see a fair amount of vertical shear from the northwesterlies coming in from the monsoon if they're too far north. We see a lot of shear from upper troughs if they're too far south. We see a lot of dry air, and this is the killer in WA, is dry air. So we see shear in Queensland too, but we see so much dry air in WA. A lot of times if we get a big ridge over central Australia, it pumps in dry desert air straight into the cyclone centre, and it kills the cyclone in a day. So it's not right to say WA systems are easier to predict. If it was, we would be in Port Hedland right now. But it's a matter of Queensland systems have so many different steering mechanisms on them, and a lot of and sometimes the topography can play a factor in that too. Can disrupt the mid-level flow into the Coral Sea. So what we would normally expect to happen sometimes doesn't happen. They do tend to be more erratic in the Coral Sea than they do anywhere else in the world, believe it or not. So the Coral Sea and the Gulf of Carpentaria are two of the most erratic basins in the entire world tropics. So there's very few places, and possibly the Arabian Sea could be another one, very few other places that have such erratic cyclonic movements than those two areas. All right. Yeah, it is a 50-50 call on neutral or La Nina conditions next year, Pico. That is, I would tend to suggest, though, that the more reputable long-term models are going for La Nina. All right, folks, I think that's, I haven't seen any more questions for me, so I think that's it for me tonight. I'll be back tomorrow, probably around about lunchtime or maybe just after lunch, and we'll talk about the landfall of Tropical Cyclone Stan. Other than that, folks, that's me signing off for the night. Thank you for joining me. Thank you for asking your questions, and I'll talk to you again tomorrow morning in your subscriber update.